some logarithmic equations that started with a logarithm. When you solve logarithmic equations, if it has a logarithm in the original problem, you need to make sure you check your answers with that. That's not going to be too big of an issue in this section, but it needs to be a habit that you build because as we go through the chapter, we get more complex logarithmic equations, and the more complex the equation is, the more often you have an extraneous solution. So you need to make that a habit. So if it has any type of logarithm in the problem at the beginning before you start working it and you're solving, you got to check your answers. Okay. If it's exponential when you start, like the problems we're going to be doing today, you don't have to check for extraneous. The reason being, the exponentials, the domain was all real numbers, so there's no restrictions on that. So when you get an x value for an answer, it's part of that domain, so it's not a restriction. So let's start with one similar to what we've done before, but I want to show you how logarithms can be used to solve. So here, we were dealing with this stuff in section 6.3, where we're solving exponential equations, and we tried to get the bases the same. That was the name of the game there. So what we did was we made this 3 to the 4x and this 3 to the third. That's what we did in section 6.2. And then we did this magic hand waving thing, and the threes that were the bases just went away. There was actually some math that happened that caused that to go away. The math that happened is if you take the log base 3 of each side, that's the part that really cancels out those base 3s. That this log base 3 cancels that base 3. This log base 3 cancels that base 3. And that's how we end up with that 4x equals 3 equation. Now in 6.3, what we did is we just dropped the 3's and said 4x equals 3 and worked it. That really is what you're doing, but this is the math that made that happen. And then you solve it from there, just like we did in 6.3. So we divide by 4, x is 3/4. What's going to happen in this section is you're going to have problems, and I don't know why I called that S. It should be R. Evidently, I don't know my alphabet this morning. Sorry. Not that it matters, but my brain wouldn't let it go. So what's going to happen today is you might have a problem like this where you can't change this side to a 3 to a power. Okay? So the difference here is that these two can both be 3 to a power, so that's why we can just drop the base 3's. Here on this side you got a base 3, but 24 is not 3 to a power. It's 2 times 12, it's 8 times 3, it's all sorts of other things, but it's not 3 to the third power or 3 to the second power, anything like that. So on this, that's where that math that made that happen comes in. Okay, so what we want to do to solve this is we've got an exponential on one side that's got a base. We're going to use the base of that exponential as the base of the logarithm. And we're going to take the log base 3 of both sides. Okay. Just like we did over here on example R, that log base 3 is going to cancel this base 3. On the right-hand side, log base 3 of 24 is a decimal number. It's a number. So we're just getting rid of the base 3 and getting that exponent with the x in it down here and getting 5x is equal to log base 3 of 24. Log base 3 of 24, again, that's just a number. Now we got to get x by itself. So what would we do to get x by itself here? Just divide by 5. Real simple step there. So x is equal to log base 3 of 24 divided by 5. That's the exact solution. We want to get the decimal approximation for that. So we're going to put that into our calculator. So this is where we're going to do the log base tool on our calculator or that change of base formula stuff. Okay, so we're going to go to the calculator, alpha window, log base. I'm going to get log base 3 of 24 and then get outside of the parentheses divided by 5. Okay. So and we'll go 3 decimal places here. I think that's what your textbook asks for. So 0.575 makes it go up to a 9. 0.579. Or you could do that by if you wanted to put a fraction in there, if it makes you feel better to do your log base that way. Some people prefer it looking exactly like what your handwritten thing looks like. Same decimal, but that way it looks exactly like it. So.
Good morning, AHS. Please rise for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Please remain standing for a moment of silence. Thank you. You may now be seated and have a wonderful day. And stay tuned for announcements.
Good morning, everyone. If you are interested in being the mascot next year, make sure you see Ms. Manners in room 117. Coach Sweat is selling FFA cords for $12. The money is due April 10th. Any senior that wants to play the senior assassin game needs to pay $5 to Ms. Wilder by Thursday, April 2nd. That is today. Prom tickets are being sold in the library. The theme is Old Hollywood. The price is $40 for AHS students. Non-AHS students get in for $45. There will be an upcharge at the door, so get your tickets early. And just a reminder, there is no school tomorrow to celebrate Good Friday. Y'all have a good one.
All right. So the log base tool, if you're if you'd rather use the change of base, you could do log of 24, close parentheses, divided by log of 3. Get that answer, then divide that by the 5. It's the same decimal. All different ways of doing the same problem. Get the decimal approximation for that. Okay? Whatever the base of the exponential is, that's the base of the log you're going to use. Okay? So it makes it, it's not a really complicated thing. It just looks weird. Looks like you're doing something really, really fancy, but it's pretty plain. Let's do this one. RST. This is T. Yeah. Alphabet's tough today. 5 to the 2x plus 7. So a little bit more complicated exponent there. Not much, but just a little bit. So the base is a 5 on the left side. On the right-hand side, I'm going to put 128. So if that were 125, we could change that to 5 to the third power and then drop the 5s. But because it's not a nice 5 to a power problem, that's where we got to use that logarithm to solve it. So on the exponential, what's the base? 5. So what logarithm are we going to use? Log base 5. So you use that log base 5 of 5 to the 2x plus 7, and then you log base 5 the other side. The beautiful thing is on the left-hand side, the log base 5 cancels out the base 5. All you're left with is that exponent. A little bit more work to do on this one to get x by itself. But all you got to do is remember, hey, we're going to treat this like a number. So what's my first step to get x by itself? Yeah, move the 7 by subtraction. Very good. So that's going to be 2x equals log base 5 of 128 minus 7. One more step. Yeah, just divide by that 2. And that whole side gets divided by 2. So x equals log base 5 of 128 minus 7 over 2. That's our exact solution. Now we want to get the decimal approximation for that. Go into 3 decimal places. So when it's one that's more complex looking like this one, that's where I use the fraction button more often. So alpha y equals, get the fraction thing going. And then I'm doing log base 5. So alpha window to get my log base. Log base 5, 128. Get outside of those parentheses, and that's where I put my minus 7. And then down in the bottom, I'm putting my divided by 2. So it looks exactly like what I wrote for my exact solution. And then it's going to give me a decimal approximation for that. So a negative 1.993. If we round to 3 decimal places. Okay, so if you don't have the log base tool, you can do the log of 128 divided by the log of 5. That's change of base formula. Get that answer, subtract 7, then divide that by 2. Okay. And there's that same decimal as we got up here. Nothing changed about that. All right, so let's do one more. Do one more while we're at it. I'll just make one up here if I can. I think I can. This little engine said. Example U. Let's say we had 7 to the 4x minus 6 equals 96. That's a good number. Good work. Good work. Okay, so key thing here is the fact that what do we know about 96? Is it 7 squared or 7 cubed or anything like that? No, it's not. We know 7 squared is 49. If we multiply that times 7, it's going to be way bigger than 96. So we know that's not a 7 to a power. So that's how I know to use logarithms to solve that. So what logarithm am I going to use to solve this? Log base 7. So I'm taking the log base 7 of both sides. Whatever the base of your exponential is, that's the base of your logarithm. That's the key to this. Once you're there, you're good. And then what happens on the left-hand side? Yeah. So all we're left with is that 4x minus 6. And then remember, log base 7 of 96 is a decimal number. It's kind of ugly number. A lot of decimal there. But it's just a number. So we're going to leave it like that until the very end. What's next? Yeah, plus 6. We got 4x is equal to log base 7, 96 plus 6, and then one more step. Yeah, divide that whole side by 4, both sides by 4, really. And so there's our exact solution, log base 7, 96 plus 6 over 4. And I'm going to get the decimal approximation for that. Just 0.6. Go 3 decimal places. 0.86. There you go. All right, so showing that. So I've got I got to get my fraction button, log base button, log base 7 of 96. Outside of that, it's a plus 6, then divided by 4. And there's that 2.8086 there for that. So, and then if you don't have that, you can do the log of 96, close parentheses, divided by log of 7, close parentheses, then add 6 to that, get that answer, then divide by 4. You're going to get the same decimal as we got with the other one. So TI-84 style, TI-83 style. Same decimals out of that. Okay. I lied to you. Let's do one more. April Fools, the day after. last one. So let's make this one a little bit different. Is that what I'm on? Nope, I'm on B. I'm telling you guys alphabet stuff today. I don't know why it is. Let's say we had e to the 7x minus 10 equals 86. Oh, just make it a number. So 86 is, can we rewrite that as e to a power? I have no capacity to even think about how to do that. So we know that's not going to work. So what do we use to solve this one? Natural log. Because it's base e, we're doing the natural log of e to the 7x minus 10 and the natural log of 86. And so this side, 7x minus 10, natural log of 86, which is a number. And now we're just getting x by itself. So once, wash, rinse, repeat. Once you get the exponential by itself and then go from there. So we're going to move the 10. Natural log of 86 is plus 10. And then last step, divide by the 7. So apparently it doesn't recognize that finger as being alive. So that's okay. It may not be. And then divided by 7. So there's our exact solution. Decimal approximation. A little easier on this one because you don't have to use that log base tool. You can just do the fraction and do natural log 86 plus 10. Is it divided by 7? I did that right. Yeah. 2.065. So mixing it up there with a little base E stuff. Okay. All right, so practice problems, page 445, 9 through 109 odds. Make sure you work some of all of them. Not saying you got to do all of those, but make sure you work some out of every section so that you're aware of